So welcome back to PCM for You channel. I'm very pleased to have you, Sigve Nakken.
Thank you.
You're a doctor in bioinformatics at the Oslo University Hospital, and you've made a presentation early on trial matching for patients. And so I would be pleased to discuss a little bit this topic with you today.
Thank you.
So my first question for you is, could you define to us what is trial matching and what it is useful for?
Yeah, so a lot of cancer patients, they run sort of out of options. So they go through the standard of care, and then when they don't respond to these treatments anymore, we have an option of recruiting them into clinical trials. So these are studies where we test sort of new treatments for patients so that they may survive longer. So this is definitely a sort of a good option for many patients when they don't have more options left.
What is useful in automatic trial matching?
Yeah, so there is a lot of ongoing trials for a lot of different tumor types. And these trials, they have different criteria for entering the trials. And it's quite a lot of work to navigate among all these trials to find out which trials actually are sort of fitting an individual patient. So to have tools that can support that process to sort of find relevant trials in a quicker or more robust way, I think is necessary because there is also a time issue here for these patients. So you cannot spend too long time.
So there's a lot of, and you're an expert on that, there's a lot about targeted treatments. So treatments that targets alteration in the DNA or the expression in tumor cells. So how do you deal with this information, either in the patient files or in the clinical trials?
That's a very timely question. So this is kind of the challenge. So we have data from the patient with their mutations, and then we want to find that information among clinical trials. But the challenge is that this information is not structured in any ways in clinical trials. So that means that we need tools that can sort of extract that information from trials, so that we can make computer programs that can actually match these things together. So that's really at the core of what I have been doing. And here we do sort of natural language processing. This is kind of the stuff that I've been involved with.
So you are able now to extract the mutated gene from patient file to have it in a structured way to match?
Yeah, I mean, to some extent. There's still quite a bit of noise, I think, in this whole process. But I think we have come quite a long way in extracting that information from clinical trials. And then I think there will be a human who have to sort of go through these results, right? So everything cannot be atomized. So there has to be a human. But we can support the interpretation.
Okay.
That's the idea.
So in Norway, we know that there is a large screening program, molecular screening program for almost all patients affected by cancer. So do you have access to this information to orient patient to trials automatically?
I mean, I don't work directly in that environment, but I have access to that information. So we can actually assess how many trials these patients are sort of can be matched against in a sense. That we can actually. So, yeah.
And do you know currently what the percentage of patients that do go to clinical trials and how it could be increased by automatic matching?
That's a very good comment. But I think so far I don't have any real data on that part. So I've mostly been trying to set up structure or a tool that can facilitate the matching. Yeah, but it will be interesting if you can apply it with it.
And so you're part of a European project on
Yep.
this topic.
Yep.
Would you present to us?
Yeah,
this
so,
project?
so this is part of the European Open Science Cloud called EOSC for cancer. So that's a project where we're trying to develop more informatics infrastructure so that things can be shared across Europe. So in one of these work packages, we are focusing specifically on clinical trials, and on this part is sort of at the core of that activity.
What are the partners for the clinical trial matching work package?
Yeah, so right now we are collaborating with Karolinska Institute. So they have a clinical decision support system known as the Molecular Tumor Board Portal. So David Tamburero at Karolinska, he's setting up a prototype where people can curate clinical trials. And we are also collaborating with a group in Bordeaux, in France, who are sort of more AI, machine learning people who will make more advanced NLP algorithms with us.
Okay. So I'm sure one of the goals is to have a tool that could be used in the clinic, in the practice, either in molecular tumor boards or for doctors.
Yeah.
So how is there a long road, or are you close to have this?
Yeah, I mean, that's a very good question. I have to say that at the stage we are now, we have set up a tool that can extract information that to actually create a ranked list of clinical trials for a given patient. It's quite a long way before we are there. And before it has to be tested by clinicians. So I think we're really only at the starting phase of this effort. But first we need to know or structure the data for each trial, and then we can sort of build on that. Okay.
What is the performance of the structuring tools? You go from free text to structured information.
Yeah.
There are a lot of tools out there.
Yeah.
So what is the performance for some applications such as mutation extraction?
Yeah, so I think I know a lot of different sort of tools that can extract mutations and genes from text, but the thing is that they have only been applied on scientific literature and not specifically on clinical trials, which may be a text that differs a bit from scientific articles. So I think people haven't really tested all these tools on clinical trials text yet. So that's really something that has to be undertaken for us to sort of evaluate performance. Yeah.
Okay, thanks a lot for this information about this very motivating project.
Thank you.
And hope to see you soon with some results, and hoping to implement that in our daily practice for personalized medicine.
Happy to discuss this.
Thank you.
Thank you.